Okay, hello everyone. This is Miss Byrd speaking. Today we're going to go ahead and talk about properties of exponents. We're going to do two rules today. The two rules are called products of powers and power of a power. Okay, so since we are continuing from the other day, from yesterday, yesterday we did zero exponents and negative exponents. And so we're going to continue today with the rules of exponents, okay? So let's go ahead and write that. So we're going to continue with the rules of exponents. Alrighty. Okay, so products of powers with the same base can be found by writing each power as repeated multiplication. Repeated multiplication. Okay, so let me show you what I mean by that. So for example, if you have 3 to the 5th power times 3 to the 2nd power, well, 3 to the 5th power would be 3 times 3 times 3 times 3 times 3. And then times 3 times 3. Okay, so here we end up with 3 to the 5th power, right? And we're combining it with the exponent of 2. So we're actually adding the exponents. And you get 3 to the 7th power. And if you go back and count this, 1, 2, 3, 4, 5, 6, 7, it matches, okay? Okay, so the rules are, the first rule, and since we're continuing from yesterday's, this is actually rule number 3. When you multiply add the exponents. And that's what we did here. When you multiply the same base, you add the exponents. Okay, so let's see an example of that. For example, if you have x to the 2nd power times x to the 3rd power. Okay, so what that means is when you multiply, add the exponents. So it's x to the 2nd power plus 3, and that gives us x to the 5th power. Okay? Number 4, rule number 4. This one is power to a power. So power to a power, you multiply the powers. Power to a power, multiply the powers. Power to a power, multiply the powers. So let me show you how that looks. For example, 2 to the third power to the fourth power. So you have a power to a power. You have a power raised to another power. So when you have power to a power, you multiply the powers. So we're going to end up multiplying 3 times 4. So you keep your base, and you're going to multiply 3 times 4. So you end up with 2 to the 12th power. Okay. So what happened here was this. If you have A times B and all of that to the m power, this can be written as the exponent goes with everything inside the parentheses. So it's A to the m power and B to the m power. And then what also goes with this is, if you see it this way, A over B, and all of this is to the m power. So the way this splits up is the exponent goes to the numerator and to the denominator. So for example, it would be A to the m power over B to the m power. Okay, so that's how you would evaluate the exponent into that expression. Okay, let's do another example here. Let's say you have 4 to the third power to the second power. So you have a power to a power. So remember that this 2 belongs to everything in here. So this could also be written as 4 to the third times 4 to the third, which if you evaluate this, it ends up being 4 times 4 times 4 times 4 times 4 times 4. And so what's happening here is you multiply the powers. So it's actually 3 times 2, and that gives us 4 to the 6th power. And if you were to count them, 1, 2, 3, 4, 5, 6, yep, there's 6 of them. All right, let's see some examples. Okay, the directions here say simplify each expression write your answers using only positive exponents. Okay, number 1. So the first example here says 9 to the 4th power to the 5th power. Okay, so do you remember the steps? This is power to a power, multiply the powers. So we're going to do 9 to the 4th times 5th power, which gives us 9 to the 20th power. There it is. Okay, number 2. Number 2 says -2 to the -7th power to the -2nd power. Whoa. Well, remember that the parentheses means that this -7 belongs to everything here, right? So this just means that your base is -2. And then your powers, you have a power to a power. So we're going to multiply the powers. So you have -7 times -2. So our base stays the same. Oops, right here is parentheses, okay? Our base stays the same. And -7 times -2 is +14. So this is our answer. Okay, number 3. 12 to the 10th power to the -6th power. Okay, so here we have power to a power, multiply the powers. So you keep your base, which is 12, and we're going to do 10 times -6. So you end up with 12 to the -60th power. Now, do you remember yesterday's rule with negative exponents? The directions here say keep your answers using only positive exponents. So you cannot leave this answer. So we're going to use yesterday's rule about negative exponents, and we're going to send this to the bottom. So it becomes 1 over 12, and then the exponent becomes a positive exponent, the 60th power. Okay, number 4. Z to the 4th power to the -3rd power. So here we have power to a power. So keep the base, and you're going to multiply the powers. 4 times -3. So it's z to the -12th power. But you can't keep this as a negative, so we're going to send it to the bottom. So it becomes 1 over z to the 12th power. Remember, the exponent becomes a positive. Okay, number 5. 6 to the -2nd power to the -1st power. Okay, so we have power to a power. You multiply the powers. So your base is 6, and we have -2 times -1. So you end up with -2 times -1 is +2. Sometimes it might ask you to evaluate. So if it does, then you would say, okay, 36. But if it's asking you for exponents, you would leave it in this form. Okay, number 6. we have w to the 12th power to the 5th power. So we have power to a power, multiply the powers. So we end up with w, keep the base, right? And we have 12 times 5. So you end up with w to the 60th power. All right, pay attention to these ones. Number 7, we have negative 2x to the 5th power to the 2nd power. Okay, so remember that this exponent belongs to everything inside the parentheses. This exponent, the 5, only belongs to the x. It does not belong to this, okay? So the way this works is we're going to get this exponent and make sure that you apply it to everything inside the parentheses. So this exponent belongs to the negative 2. So you have negative 2 to the 2nd power, and then you have x to the 5th power, and because it's power to a power, you multiply the powers. And now we're going to evaluate. Well, negative 2 to the 2nd power is 4. And then here, when you multiply the powers, you end up with x to the 10th power. And we are done. Okay. Number 8. Okay, so number 8 says negative 2x to the 5th power to the 2nd power times 2xy and all of that to the 3rd power. Ooh, look at this one. Okay, so we're going to break it down step by step, okay? Let's, do you notice how this beginning part is actually the same as this part, as number 7? So we already know the answer when you evaluate, right? This 2 belongs to everything in here. So we end up with 4x to the 10th power. And then we're going to multiply it with this. So this exponent 3 belongs to everything in here. So it's times 2 to the 3rd power, x to the 3rd power. Now look, remember there is an invisible 1 there, and this is a power to a power. You multiply the powers, so it's x to the 3rd power. And then here the y has an invisible 1 as well, power to a power. You multiply the powers, so it's y to the 3rd power. Okay, let's go ahead and evaluate this. This right here, 2 to the 3rd power, means 2 times 2 times 2. And so I'm going to bring down 4x to the 10th times, when you evaluate this, you end up with 8. And then the x to the 3rd, I'm going to bring it straight down, and y to the 3rd. Okay, so now the next step, because we're multiplying, you're going to multiply these whole numbers. Well, they're coefficients. So we're going to say 4 times 8, which gives us 32. And then the x's, we have x to the 10th power times x to the 3rd power. Well, when you multiply the bases, you add the exponents. So you end up with x to the 13th power. And then y to the 3rd, there's no other y to the 3rd, any other variables that match it to multiply with. So it's on its own, bring it down. And this is it. We evaluated it. It's simplified. Okay, I'm going to move on to the next page. Okay, so this one is number 9. We have 3 to the second power times 3 to the sixth power. Okay, so when you multiply the same base, you add the exponents. So here we have the base is 3, and we're going to add 2 plus 6. So you get 3 to the 8th power. Now, if it asks you to evaluate, you would actually do 3 times 3 times 3 times 3 times 3 times 3, 32. 8 times, right? So you end up with this answer here. But if it just asks you for the exponents, then you would leave it like this. On your homework assignment, your answers will be in exponential form. Okay, number 10. Number 10 says 10 to the 4th power times 10 to the negative 6th power. Okay, so the bases are the same. So when you multiply, you add your exponents. So we have the base 10, and then 4 plus negative 6. Okay, so here we have different signs, so we're actually going to subtract, keep the sign of the bigger number. So we end up with 10 to the negative 2nd power. But we can't keep it as a negative, so we're going to send it to the bottom. So it becomes 1 over 10 to the 2nd power. So you would leave your answer in exponential form, unless it's said to evaluate. If it says to evaluate, then you would evaluate 10 to the 2nd power, which gives you 1 over 100. Okay. Number 11. X to the 9th power times x to the negative 9th power. Okay. So the rule is when you multiply, add your exponents. Okay, try it real quick. All right, let's see how we did. So you keep the base, and we're going to add the exponents. So it's going to be 9 plus negative 9. Well, 9 plus negative 9 is 0. And x to the 0 power is 1. So our answer is 1. Okay, number 12. We have 3x to the 5th power times 2x to the 2nd power. Okay, so this one looks a little different because now we have coefficients right here. So because we're multiplying, you would multiply the coefficients with each other. So we're going to multiply 3 times 2, which gives us 6. Now your variable x to the 5th power multiplied with x to the 2nd power, well, it's the same rule up here, right? When you multiply, add your exponents. So we're going to say x to the 5th power plus 2. So it's actually 6x to the 7th power. Okay, please do not write parentheses like this. This would mean that the 7 belongs to the 6 as well, and that's not the case. So don't write the parentheses unless they were already there. Okay, number 13. Okay, so we have 2 to the 3rd power over 4 to the second power, and all of this is to the second power. So here what's happening is power to a power. And here, this is also power to a power. So we're going to keep the base. And power to a power, you multiply the power. So 3 times 2 is 6. Over, here you have 4 to the second power. And power to a power, you multiply the power. So 2 times 2. And we get 4 to the fourth power. Oh, and that's it. We're done. Number 14. All right, here's our last one, okay? Number 14 says 2a to the third power, and all of that to the second power, times negative 3a b to the third power to the second power. Okay, so I usually like to break it up. So we'll work on this first part first and then the second part. Okay, so this exponent 2, remember that it belongs to everything inside the parentheses. So this is actually going to be 2 to the second power. And then here you have a, and it's 3 to the second power, right? A to the third power and then to the second power. So you have a power to a power. You multiply the powers. So 3 times 2, 6. Okay, now we're going to work on this part. So this 2, the exponent belongs to everything inside the parentheses. So here the negative 3 is to the second power, right? Well, negative 3 to the second power means negative 3 times negative 3. And negative 3 times negative 3 is 9. So right now I have 9, and then a to the first power times 2, right? Because it's power to a power, so you end up with a to the second power. And then here b is going to be power to a power, multiply the powers, so 3 times 2 is 6, so b to the sixth power. Okay, so this is all together because this is being multiplied, right? And so then we're going to multiply the coefficients, right? Oops, right here, 2 to the second power, I need to evaluate that one. So it's actually, let me write it here, 4a to the sixth power, and all of that times 9a to the second power, b to the sixth power. Okay, so we have to multiply the coefficients. 4 times 9 is 36. And then we're going to multiply the same bases here. When you multiply, you add your exponents. So you end up with a to the eighth power. And then b is alone, so you just bring it down, b to the sixth power. And here is our final answer. Okay? Okay, so that's it, guys. We are done. I know it was a lot of notes, but thank you for hanging in there.